Okay, so hello and welcome. This is the Kubernetes SIG storage community meeting on per volume CSI capabilities. Where we left off last week was I think we kind of rejected relying on splitting CSI drivers apart as the way to solve this. And the best available alternative that we've come up with so far is this concept of formalizing subtypes. And Michelle had said her concern was when you're trying to schedule a wait for first consumer PVC, the scheduler needs to be able to make the decision with only access to the PVC in the storage class, right? And so you won't get the subtype information from either of those.
Wait, but before we conclude, like I don't remember discussing that we agreed to reject that, because at least in my mind, that seems like the only viable way that solves all the problems.
Well, I mean, okay, so
sorry, yeah,
no, I mean, it's fine. It's fine to keep pushing that opinion. I think what we had come around to was like all of the kinds of things we would do to simplify splitting apart CSI drivers are things that we should do, but that given how much momentum there is around the existing CSI drivers that rely on the ability to have a single storage class and to make the decision about what type of volume to give you internally, with the entire PV spec in mind, it's unlikely that those drivers are going to be split apart, right? That's the big concern. Is like, will a NetApp actually rewrite Trident to have multiple CSI drivers? Will a VMware actually rewrite their vSphere driver to have multiple CSI drivers? Like, it seems unlikely, even if like we say that's the way to do it. Like, I think the outcome of that would just be that the problem will not get solved because we'll keep doing what we do today. So, and no one has proposed a truly workable scheme for having a single default storage class that basically lets the driver decide what type of volume to give you based on the specifics of the request. Right? We went through the details of like, well, if you tried to do some sort of a mutating webhook that would like pick a storage class of the appropriate type for you just in time, like that webhook would have to do all of the work that the CSI drivers are currently doing to make that decision, which is something you can't do quickly. And so like I feel like we came up empty on the solution to that specific problem.
Okay. So on that particular problem, I think the scheduling decision that the NetApp driver makes for like it's a little bit unique in that sense. And like I said, I don't have enough background on that to know what needs to be done. But for driver that I know, vSphere CSI driver, Azure file driver, it's pretty easy to make the decision in that webhook, because all they do is they look at the access mode and but for
yeah, and I can live with that being the official stance is like, okay, we need to take the vSphere driver and split it up into two, and we need to take the Azure driver and split it up into two, and then the NetApp driver will just continue to be broken, forever, and like that.
I don't think our driver will be split.
What?
It's just not likely to happen. Maybe Hamad, you can do it, but I do not think, given all the amount of work, even like how long we can actually do one release, it's just like two drivers that will double the work, right? So
no. I was saying like the part where the storage class is assigned, it's easy in vSphere.
We only have like two right now. We only have two types. I think Trident needs to have more. Three,
and
four,
the other thing I was saying is that we don't have to even release two images. The way forward that we discussed in the last meeting was single binary, listening to two sockets,
right,
and responding. And so it's like technically it's not. I mean, like if we have to, like we could, Red Hat can make the change in vSphere CSI driver if VMware is willing to accept the patches. It doesn't have to be in a new image. It would be the same image doing both the work, and it would work.
Well, but what about the migration plan for existing PVs? Like you'd have to solve that too.
Yeah. And
it's not just code change. Come on, that's the thing. Right? Or the testing, that's the part you cannot replace. That you have to, unfortunately, yeah. But anyway, I think, yeah, I don't think we are going to make progress just by talking about this part, right? It's not, we are not the one who are going to make this decision anyway.
We should talk about both the parts.
So can we maybe, okay.
I don't want to rule out that other approach. I just want to say that I feel like we've reached the end of the road with what we can do there, and we know there's a bunch of useful work to do to combine CSI drivers, whether or not we do that. So like, I don't want to stand in the way of any of that work moving forward, but like I wouldn't be contributing to any of it because I wouldn't benefit from any of it. So like, go ahead and make all those changes to like allow, you know, combining sidecars and things, because it will benefit a lot of people.
Yeah.
But
go ahead.
But yeah, like as long as we believe that there's value in having a single storage class where the driver uses some opaque black box to actually decide what kind of a volume to give you, which is at least how Trident works today. And one can imagine getting a lot of other useful benefits out of that style of scheduling, where it's just a decision that the driver makes, and then it tells Kubernetes. Then I don't see any alternative other than some sort of formal subtype. And so that's sort of where we had left the previous meeting is yeah, I don't want to say we're not doing the other thing. I just want to say that I don't see any path forward on you know, I guess doing design work, right? We know what needs doing there, and we can go ahead and do it. So getting back to the idea of having a formal subtype, I wanted to propose this example driver. I just wrote a little bit of text in the notes before the meeting. So imagine an example driver that it can make two types of volumes, and I'm calling them pink and green, just to be totally abstract. And the decision for whether you get a pink volume or green volume is based on some complex internal logic, because we have to assume this. And then imagine that for technical reasons, nodes can only have 10 pink volumes and they can only have 20 green volumes, right? So in the subtype proposal that we had made, what we would do is when you called node get info on the node plugin, like it would return as part of its gRPC response, subtype pink 10, subtype green 20, and then Kubernetes would have that information and it could make its way over to the scheduler. And then the idea is when you're scheduling a volume or scheduling a pod that's attaching to a pink volume, you can go look at the node and see how many pink volumes there are. And if it's less than 10, you can schedule it there. And if it's 10, you can't. And so you can imagine all of that. And Michelle's specific complaint was, well, what if it's a wait for first consumer volume and it hasn't bound to the PV yet, right? So now all you have is the storage class, which gives you the driver type, and the PVC, which gives you all the other information about it, but you don't have the subtype yet because it hasn't been created yet. So basically, excuse me, the best you can do here, as far as I can see, is, well, you do know for the existing attachments on each node, like if you're considering a given node, if there are only 9 pink volumes and 19 green volumes or fewer, then it doesn't matter what kind of volume you were going to get, right? Because it could be pink or it could be green and it would still work fine. So if the scheduler is able to look at a node and count up the current number of attached volumes with each subtype and compare that to the maximums for that CSI driver and observe that all of them are not at the cap, then it could proceed and say, well, I'm going to go ahead and put the pod on that node, and then because the subtype isn't going to matter. Of course, if you had either 10 pink volumes or 20 green volumes, at that point, it does matter. And the only safe thing to do from the scheduler's perspective would be not to choose that node and to go pick another node. And that actually doesn't seem like such a bad situation from my perspective, right? Because this is going to be a pretty uncommon situation anyways, when a node actually has the maximum number of volumes of any given type. And It's also, you only have these kinds of situations when you have wait for first consumer, because if you go ahead and bind the volume ahead, before scheduling the pod, then you will know the subtype and you'll be able to get exactly at the limit. I had been considering last week saying that, well, maybe what the scheduler should do is just use the smallest, or just use the limit for the unknown type volumes, right? The existing max volumes per node value, or the integer value that's in that get node info RPC response. And so for this driver, that number would have to be 10, right? Because if you don't know what the type is, you have to assume the worst case it's pink, and you have to assume that you can only go up to 10. But that's actually too conservative for the unbound case, right? Because if you know that you have more than 10 volumes, but they're all green, then it's still safe to create a volume of unknown type as long as there aren't 20 green volumes. So I guess my proposal is, like, this is actually not too big of a deal. If we can teach the scheduler to just count up attachments for a given volume type by subtype, and then look at the maximums for all of the subtypes for a given volume type, and we would have to assume that the information coming back from the node plugin was comprehensive, and that there wasn't a third unknown type that it could potentially create. Then you could say, well, all of the attachment limits are below their maximums, and therefore it's safe to schedule the pod, because we'll definitely be able to attach the volume, at least modulo any race conditions. I actually don't know how the scheduler handles race conditions. If multiple pods are all trying to land on the same node, they all have wait for first consumer PVCs, and they're all of the same type, is there going to be a race and one of them will win and the other ones will lose? I actually don't know how that works, but this certainly wouldn't be any worse than the status quo in that regard.
Yeah, I think the scheduler counts like all the in progress attachment towards the limit, and
but the attachment wouldn't be in progress until the pod lands and the PVC gets created.
It like, counts, right? But it counts like as if it has been attached.
Okay,
so it's still in progress.
So it's smart enough to know that there will be an attachment of a certain PVC type. Okay, so in that case, what it would have to do is temporarily reserve one of each subtype volume, right? So if you had 19 green volumes and 9 pink volumes, and you were provisioning a new one, you would have to assume that it was both green and pink for the purposes of preventing other nodes from scheduling there, right? Until you knew whether it was actually pink or green, and then at that point you could fix the math. So it seems like a tractable problem. I mean, you will have certain pathological cases where, like, you've maxed the number of green volumes, and it turns out that it would have given you a pink volume, but there's no way to know that in advance, so you end up not picking that node, and like that's suboptimal. But it seems pretty close to optimal from where I sit, and I feel like we probably don't actually hit node volume limits maximums in practice too often, or at least not on a majority of your nodes. So like, even if a few of your nodes are at the maximum, you'll probably find another one that isn't at the maximum, and you'll be fine.
Yeah, it depends. Some, like in AWS, like in cloud environment, nodes are too packed, like where they're running, and the limits are too small, like 10, 24, such low numbers. If the other cases, its limit is higher, but like for take Azure disk, I think the number is lowered. So it depends, like whether they're running on how tightly the nodes are packed, I guess.
Well, I mean, in the case of the ones that I actually care about, like NFS and iSCSI and NVMe that NetApp supports, the limits are infinite, right? We don't actually have a maximum number of NFS mounts or maximum number of iSCSIs. So it doesn't actually matter to us. But in the case where it did, I think that this scheme would address the problem.
I forgot what the limit on Azure was. Azure was like in case of AWS, for example, where the limits are low, and I know I'm very familiar with. In that case, like the drivers, EFS, for example, the file system driver is separate. So they don't run into this issue because the block storage and shared file storage is different. For Azure, something where the drivers are saying, actually Azure, the drivers are different again. So but there's the same driver that ships different type of volume. So the only place where like I know of a practical driver where it matters is vSphere, where it's the same driver that supports blocks and file system both, and it has upper limit of I think 56 volumes for the.
So if we went ahead with this scenario and implemented subtypes, could you express, there is a low limit for the block volumes and a higher limit for the file system volumes, and then expect that you'd stay out of trouble with regard to scheduling volumes? Because you'd never hit the higher limit, and it would always be a question of when the scheduler was deciding whether a pod can go on a node, is that lower limit at the max or not? And if it's not, it would still schedule the pod. And if it is, then it would, I guess there's still the bad case. It could have been a file system volume and you didn't schedule it because you would run out of block volumes.
Yeah, but in vSphere case, you run out of resources on a node far sooner before you run out of the node limits. If that makes sense, like 56, if it's the limit, then the maximum number of volumes you can attach to a node is 56. Then like you're likely to run out of resources on the node sooner than you will run out.
I believe that, but we wouldn't have implemented the node limits feature if it didn't matter somewhere.
Yeah, right? It matters for like for AWS and cloud instances much more because their limits are so low. And vSphere, like only the CSI driver supports limit. The entry driver, for example, doesn't support it. So,
but those drivers that you mentioned that have the low limits, they're not going to be doing subtypes, right? So again,
at least
they wouldn't get into trouble.
Yeah, they're not going to doing subtypes. That's true. Yeah, the only one I know is vSphere, and the limits are far higher. And so in practice, like of the drivers we know about, it's going to be fine. Yeah, it's going to be not a end of the world, but obviously Michelle and all, they're going to look into from the perspective of like whether it scales to support other driver types or not. Just because it works for driver in front of us, does it mean work from all of the drivers? That's the question.
Why? I mean, can you theorize a driver that it would not work for? Because that's
like say if vSphere CSI driver was like support volume limits support was lower, like 12 or 15.
Yeah.
Then you would run into problem because the network path and everything for the file is vSAN file is completely different from the block storage, and you can actually attach more than 16. The NFS vSAN shares, you cannot attach more than 16 blocks. This thing, so you will run into this problem.
Okay, but I mean, if we could. You're saying even if we had the subtypes and we could properly express those numbers, you think the scheduler would make the wrong decision on a high enough frequency with a high enough frequency that we would be upset about it?
Yeah. For example, if the node limits were lower, for sure. Yeah.
But why? Like you think that you'd have situations where you get a combination of the node is maxed out its number of block volumes, and there is a new pod coming, and it has a wait for first consumer PVC, and that PVC would have been a non-block volume, a file system volume, then the scheduler will say it can't go on that node when it actually could have. Like that's the only failure mode I can think of. And that seems like a tiny corner case, right? Like a lot of things have to go wrong and right at the same time to end up in that boat.
It's not tiny corner case. It's least like say in case of vSphere, for example, the limits are configurable, and somebody admin can configure the limit to be like 16, and then they already attach 16 volumes and they're running pods. Maybe it's a 32 GB or 16 GB RAM node, and then they want to attach some shared file systems. They could still attach it, but the scheduler will not prevent it because it's counting the limits.
Okay, so what could we do in that situation to address it? Like if I'm an admin and I know that, like, okay, I'm constrained on these block volumes, and the scheduler might not put certain pods on certain nodes if they run out of block volumes, and I need to now somehow give a hint to the scheduler that says, I actually know that this PVC is going to be a file system volume and not subject to the limits. And I got to get that hint all the way into the scheduler so that it can choose to put my pod on that node. Like what can we do other than providing? Go ahead.
Yeah. So there's one more thing we could do is there's a environment variable called cube max PD volumes or something. And just a second, sorry. Yeah, so yeah, and that we stopped respecting in scheduler for a while once we migrated to CSI volumes. But that basically defines global limit on the node. I mean, theoretically, we could have an environment that was, it's been supported since forever, but now with the CSI, the support of that environment variable is kind of iffy. Cube PD max volume, that defines like the, so if we could provide that environment variable, like you could have a way of temporarily overriding the limit. But then again, that limit is global for the entire cluster. So,
well, no, I was thinking of something that less global and more tailored. Like imagine I had a second storage class that had some opaque parameter that forced the driver to give you a file system volume, right? So any PVC from a particular storage class will have a known subtype, even if Kubernetes doesn't know it, right? Then is there a way to basically also annotate the storage class with information to the scheduler that says, okay, scheduler, we don't, we're not going to put subtypes into the storage class as a formal part of the design, but like we could provide a hint that says, I happen to know that any volume provisioned by this storage class will have a certain subtype because I've arranged for that to be the case. And then the scheduler could say, okay, well, I can see the storage class of this unbound volume, and I can see that it will definitely be a file system volume. And therefore, even though the block volumes are full on that node, the file system volumes are not, and therefore I will go schedule it anyways. Like, can you imagine
that's something that could work, but that's interesting. But it will have to kind of flex out the design, how it will look like how you flex out the subtype design. I think we have to see how this hint on the storage class will look like.
I mean, we could just have a first class subtype field and just allow it to be empty and then define what empty means.
Okay.
But then say if it's full, then, well, I guess the trouble is if we define that populating that field means that you're definitely going to get a volume of that subtype, we have no way to enforce that that's actually true, right? Because it would just be an assertion made by the admin that I know that volumes from this subclass will be this subtype, or from the storage class will be this subtype. And then if the admin was wrong about that and you get one of the other subtype, then you get really bad behavior. So yeah, maybe just like an annotation that's a hint that says, hey, I'm the admin and I'm hinting that I know, but it might be wrong because admins make mistakes, right?
Yeah. I wonder if during provisioning we could introduce like a two-step process of provisioning. We already have like two-step provisioning sort of where the entry provisioner creates the PV and the external provisioner binds it.
I mean, you could have a formal subtype field and allow them to leave it blank, in which case it really is up to the driver. But then if it's filled in, we could actually check it, right? We could say, okay, this storage class is for green volumes, and there's going to be something in the storage class that indicates to the driver it must create a green volume. And then if the driver returns anything other than a green volume, it's actually an error and it fails to bind, right?
Wait, sorry, say that again. I was thinking something else.
Imagine that we did add a formal subtype field to the storage class.
Oh, okay.
And we allowed it to be empty, in which case you would get the behavior that we're proposing here, where the driver really does get to decide. But if you filled it in with something like pink or green, and then the driver returned something other than what you said, like we would fail to, that would be an error, and you would fail to bind, and basically you just have a broken PVC. and it would be the admin's fault or the driver author's fault, right? But at least Kubernetes would catch the error at bind time and not allow further bad things to happen.
Yeah. Just a random thought. I was thinking like could we do like counting at a label where like scheduler counts the labels, like the PVs, like we do two-step counting. One is like, okay, how many PVs are of that type, driver type, and then we provision the volume, we fill the PV type, like the subtype of the PV, and then scheduler can count the type. Like, can we do something like that?
The problem is if you were full on green and not full on pink, and then it happens to be green, like now the pod really can't go there, and you have to delete the volume you just created, right? That's the issue. Is if you go all the way through the process of creating the volume for a particular node, and it turns out that you stepped over the limit, now you have to unwind the thing you just created, delete that pod and delete that PV, and go try again somewhere else. And so we were trying to like get ahead of it and say, either we know this is safe regardless of what happens, in which case go ahead, or use some hint from the admin that says, I actually can promise you before you create it, it's going to be of this subtype. And so as long as you trust that hint, then you can go ahead.
No, I was saying that before, like, this is, I'm not sure if it will work, but yeah. No, like rather than like creating fully, like the creation call resulting in creation of complete PV. I wonder if there's a way where we could just fill in the subtype of the volume. Like, okay.
Oh, okay. So like something you call it the RPC layer before create volume. That's like create volume.
Yeah.
And then it returns back what the volume will look like.
Yeah, and then scheduler counts that. Okay, I need this. Yeah.
The problem with that is you would have to use it always, and you would have to, and it would become part of the life cycle of every volume that, sometimes you'll go through pre-create and then never follow it up with a create, and now you have a mess to clean up. Sometimes you'll call pre-create and it will succeed, and then you'll call create and it will fail. And what's the error recovery path from that sequence? Like it makes using CSI dramatically more complicated. And I mean, it's bad enough that, create can fail and leave garbage behind that you have to clean up with delete, right? That's bad enough.
But in this case, you did not create. You're just the scheduler is just the provisioner is just making a call to the driver to fill the subtype, like what the subtype of the volume is going to be, and then.
But unless you allow the driver to create state at that time to at least reserve the space that you created, then it could fail, right? You could say pre-create and it will tell you it's going to be this type, but then if you wait a long time and someone uses up all that space and now you try to call create, it might not work anymore. And so now you need like an unpre-create to undo what you did in the pre-create after create itself fails, to clean up, just to clean up the state. So you'd be forced to develop the extra layers of retry and error handling around the pre-create, no matter what. Even if you're not supposed to create anything at that layer, drivers will create some amount of state that just represents a reservation.
That I'm going to preserve this volume. So it's kind of hard to solve. I mean, I do see the point of that. That being corner case for this thing. I just don't know if it'll be acceptable, or like it does worry me a little bit, because for some drivers it would matter a lot. For some others it will not matter. It's kind of tricky. One of the things, I don't know. Did Michelle agree to that? Michelle, if they agree, then we have to, maybe we can write it down in the proposal and see what other things.
Well, I mean, I was going to present this to Michelle if she could join today, and she was going to up until the last minute. She even said she might join at like 1:30, but it's past 1:30 and she's still not here, so probably something happened.
Yeah.
But I mean, we can wait until next week and try again. After talking about the idea of like putting this subtype into the storage class, I'm starting to like that a little bit more because it actually does help. But I'm worried about how the heck you document that for storage classes are confusing enough. If we add this field that says like you should leave this empty to get correct behavior, but in this one really weird situation where you know what's going to happen, then you should fill it in. Like that's just hard for a user to understand, right? Like I'm imagining the NetApp case where it's like I know that there's arguments you can pass into the storage class parameters that will guarantee that you get an NFS volume, and like in that situation, you could safely put NFS subtype in your storage class, and then the scheduler could take advantage of that knowledge and be smarter. But like,
I don't know.
I don't know how we would document to our users that like that's what you're supposed to do, because someone could just as easily like put the NFS subtype in the storage class and then not put the other stuff that guarantees you're going to get an NFS volume, and then they'll just have a bunch of errors and they won't know why. And that doesn't seem like a great user experience, right? The whole idea here is this is supposed to be kind of hidden and magical. You just have a storage class and you provision some storage and it works. And I'm worried about creating more error conditions.
I have a question that like, so how common it is that a user request like a general storage class and from a general storage class, and they get NFS or iSCSI, whatever. It seems like, to me, it seems like depending on workload, like NFS might not be suitable to run certain workload, only iSCSI is required for certain workload. So yeah. like in my use cases where I have seen, customers know what type they want. They don't want storage subsystem to arbitrarily give like a different volume of different type depending on availability and like this thing.
I guess in my experience, what it usually comes down to is you have some infrastructure guy who's set up the cluster itself, right? And they've purchased the hardware and they purchased some sort of storage hardware solution or storage software solution, and they build it all up, and then they put storage classes on there, or at least one storage class. And then the people who consume the cluster, very often are like deploying Helm charts or just stuff they got off the internet. And those don't have storage classes in them, right? They just have PVC definitions with a blank storage class name that says I need raw block volume, or I need RWO file system volume, or I need RWX file system volume, whatever the application needs in its manifest. And the idea is that we can, given a single storage class, we can satisfy any of your requests, right? If you ask for raw block, you're going to get iSCSI. If you ask for RWX, you're going to get NFS. If you ask for RWO, you might get either one depending on how we're feeling that day. I mean, there's a bunch of specific things that would determine what you would get. But the idea is your PVC definition specifies what you actually wanted, and the storage class is just a way to get there. Or if you have multiple storage classes, it's because the admin was trying to actually give you certain meaningful choices like high performance and low performance, or this policy or that policy, or some other sort of choice that you couldn't have made inside your PVC definition itself.
Yeah. No, I just this use case of dynamically deciding PV type, it just seems a little bit like strange to me. Like imagine if I had I'm asking for like I don't know, asking for I need a block volume, so I specified read write once, and then because there was no block volume available in this thing, it gives me NFS volume, and then now I'm trying to run Postgres on top of NFS, and it's just not going to work.
Yeah. No, we get those kinds of bugs. I actually think you can with the proper hacks. But yes. I mean, we have those kinds of, but that's a problem introduced by Kubernetes trying to abstract storage a little too much, right? Kubernetes creates the fantasy that all file system volumes are the same, and then all you have to do is ask for a file system volume and you'll get something that works. Yeah, in reality, that's not always true. And people that have a deep understanding of their cluster will, they'll use the various tools available to ensure they get what they want. But I actually think those are less common, right? In a lot of cases, you just have infrastructure and you have people consuming infrastructure and they don't really talk to each other.
I don't, yeah, and like the whole reason I'm saying this is because that if you're going to follow through with subtype, it doesn't seem too bad to put subtype in storage class to me. Like have.
It doesn't seem too bad. I agree with
yeah,
that.
like
we could do it. It's just we'd have to be very clear about, you know, the additional ways that this can go wrong, and the docs would have to have some caution markers, like, you know, make sure that you understand what you're doing, because this is not a request for a certain subtype. It is a check that what you get back matches the subtype, right? That's what it would end up being. Unless we also amended the CSI spec to create a channel for the provisioner sidecar to shove down the subtype alongside everything else. Or maybe that's what we do, right? Maybe we define a special CSI provisioner namespace prefix for this subtype, and we just pass it along as one of the opaque parameters like we do some of the other ones, so that it is available to CSI plugins that want to know what the subtype of the storage class was so that they can respect it. We could do that.
Yeah, I mean, that that
would at least shift the error detection left, right? If you explicitly communicated the NFS in the storage class and that made its way all the way down to the plugin at create volume time, then you could notice that you were never going to get an NFS volume and immediately return an error before you even create a volume.
Yeah. Yeah, it seems to me, like this. Yeah. If we're gonna do the subtype, we should like do it as, I don't know what other people call thing, but it might be better to get more. It might be easier to get more buy-in.
If it was more formalized, okay.
Yeah.
All right. Well.
Sorry, I'm brinking. Sorry, I have to. Okay.
You got some boisterous kids.
Yeah. Lunchtime.
All right. I guess anything else?
Yeah, just a quick question. So I guess the assumption there is like if we do end up adding a subtype to storage class, this would match the one defined inside the PV, right?
Yeah.
Okay.
Yeah, but I guess we would need to figure out exactly what the CSI spec change looks like then, because I guess you would always need it to come back in the case that the request was empty, right? If you didn't care what subtype you get, then you really do need to know when it comes back, like what it is, right? So in the case of a blank subtype, it would not need to match.
Right.
Blank means I don't care. But yes, in the case of a specified one, it would need to match. And so we would need to have a way to pass it in. We need to have a way to get it back out. We would need to have error checking to make sure that they didn't differ.
Yeah.
Which none of that would be too bad. And then we could plumb all that over into the scheduler so that it had the per node volume limits for each subtype, and then the scheduler would be able to look at the storage class as well to get an additional hint that, but if the hint was not there, it could still function. It would just have to look at all of the possible subtypes and make sure that all of them were not at the max before scheduling the volume. And that's probably a little bit of nasty code in the scheduler that would be required to do it, because you'd have to loop and possibly reserve a bunch of sort of pre-existing volumes, or not pre-existing volumes that don't exist yet.
Yeah.
And then after the volume does exist, then go back and fix all those numbers, so the scheduler always has an accurate count of what's really attached to that node. But you could do it.
Right. Yeah, sounds like a lot of work plus like a bigger error surface for little bit of gain. I don't know. Yeah. But anyways, thanks, man. I appreciate you putting all these thoughts into this.
Sure. Yeah. And I mean, maybe this just remains at the design stage for a while and we don't actually push forward with it. But I feel like if we really do want to solve these kinds of issues we're having with kubelet and with things like the SE Linux policy or the FS group change policy and the SE Linux relabeling, like those kinds of things that it works sometimes and not other times, I don't see any way other than this. And the alternative is just to not solve them and tolerate the pain for a while, or do like Haman suggested and encourage drivers to start splitting apart into multiple drivers, because that's also a viable solution. It's just one that I'm confident certain vendors will not take. So
yeah, it's hard to go back to them and say, hey, guess what? Yeah. But I think overall, though, I still think that the subtype solution will solve the original issue which motivated this conversation, like around the FS group policy and stuff like that. So
yeah,
cool.
All right. So regarding future meetings, I don't know if we need to keep having these. I guess I want to get Michelle's reaction to this, and maybe she can come next week so we can keep that meeting on the calendar. But until we do get some sort of agreement and a plan to do any kind of implementation, we might just say, okay, we have a design, and then put it on the shelf, or
Do you want to just check with her offline? Because
I can try to do that. I can try to do that. Yes.
Maybe that's actually better. I mean, if there is need, then we can schedule a meeting, right? Otherwise, I mean, every time we have the meeting, most of the time.
No, you're right. You're right. There's no reason that I couldn't have a one-on-one meeting with Michelle and just get her feedback. It's just that it wouldn't be captured in the, in the recording, and people, if we did have any interesting discussions, no one else would hear about it. So
you could also
it would be better to do it here,
right?
but
you can still record it if
that's true. That's true. We could record another one.
You could record. I can help you upload it. I mean, if you want, I mean, that's fine. That's not a problem. And because since we don't know whether she will join or not, and then we end up having the same thing. So yeah. Probably, yeah, if you could just get her buying on it, and then.
Okay, I will attempt to do that. That's a reasonable approach.
So probably better just to cancel this, and then we can definitely schedule it if if we have a need and if we have more people join the meeting. That's not a problem.
Yeah, we can end the series of meetings. We can put an update in here and say we may resume it in the future, but for now we've gone as far as we can go, and I can follow up with Michelle offline. I like that.
I forgot. Did you schedule this meeting or did I? Oh, I scheduled this meeting probably. Okay, I'll cancel.
Yeah,
okay.
Yeah, you own the meeting, Xing. Thank you.
All right. Okay.
All right. So I think we can end a little early unless anyone has anything else.
I think we're good. Thanks, everybody.
Right. Thank you.
Thank you.
Cheers.
Bye.